LWO1 WeatherNet, liftoff conditions. LWO1 WeatherNet, liftoff conditions. Looking pretty good.
ESTS is ready for launch.
Ignition. Liftoff.
Falcon 9 has cleared the tower.
Ten, 9, 8,
Side booster ignition.
6, 5, 4, 3, 2, 1.
On your screen is a live view of the Falcon 9 at historic Launch Complex 39A, awaiting its 1 a.m. Eastern Time launch from Kennedy Space Center in Florida. Good evening and welcome to our launch coverage for IXPE, or the Imaging X-ray Polarimetry Explorer for our customer NASA. My name is Shiva Bharadwaj, and I'm a space operations engineer, and I'm joining you from SpaceX headquarters in Hawthorne, California. The Imaging X-ray Polarimetry Explorer is NASA's first mission dedicated to measuring the polarization of X-rays from a variety of cosmic sources, objects like black holes and neutron stars. We'll have a little more on the science IXPE will conduct a bit later on in the webcast, but for now, let's take a closer look at the rocket on your screen. This is Falcon 9, our two-stage liquid-fueled launch vehicle. It's standing vertical at Launch Complex 39A. Now, the booster supporting today's mission is flying for the 5th time, and this also marks SpaceX's second flight-proven launch vehicle for NASA's Launch Services Program, or LSP. Now, this booster first flew in November of last year. It since has carried 3 Dragons and 8 astronauts to the International Space Station on the Crew 1, Crew 2, and CRS-23 missions. It also flew the Sirius XM-8 satellite to orbit earlier on this year. Now, if you're new to our webcast or unfamiliar with the Falcon 9, that bottom 2/3 of the vehicle is what we refer to as the first stage. It's covered by some white clouds around it, but it's also covered in some soot from its previous flights that you might catch in between. Now, the first stage's primary role is to accelerate all the way to the edge of space with the help of 9 Merlin engines that it has at its base. There, it'll drop off the second stage and the payload. Then, the first stage will make its way back to planet Earth, where we'll attempt to recover it on our autonomous drone ship named Just Read the Instructions. Now, if you turn your attention back to that section above the first stage and above that black carbon fiber interstage, you'll see Falcon 9's second stage. About 2.5 minutes into the flight, the stages will separate. The second stage will ignite its single Merlin vacuum engine and carry itself and the IXPE payload into a circular orbit. Now, if the launch wasn't cool enough, IXPE also marks the first Falcon 9 launch into an equatorial orbit. That means that the satellite will fly into an orbit that goes along the equator, which we refer to as having an inclination of about 0 degrees. Getting to an equatorial orbit from Florida requires a lot of rocket performance and propellant, so we won't be able to land the first stage back on land. Instead, we'll attempt to land the first stage on our drone ship stationed off the coast of Florida, while the second stage completes its orbital insertion burn. Now, the second stage will perform a second burn about 20 minutes later to get to that final circular equatorial orbit, followed shortly after by satellite deployment around T+33 minutes. Today's mission also marks the smallest dedicated payload that a Falcon 9 rocket has ever launched by a pretty large margin, making for a very roomy payload fairing at liftoff. Now, speaking of which, the fairing is that nose cone structure at the very top of the vehicle above the second stage. The fairing protects the IXPE satellite from aerodynamic heating, loads, and contamination during the ascent portion of the mission. Now, it's made of 2 fairing halves. Both of those are brand new today, and we're planning to recover them on our recovery ship named Bob, which is stationed out in the Atlantic Ocean.
Bob, I remember that ship.
Now, we're coming up on about T-minus 12.5 minutes to liftoff. The launch vehicle and satellite teams are continuing towards an on-time liftoff, scheduled for 1 a.m. Eastern Time. Falcon 9 team began their final checks at about T-minus 2 hours. Most recently, we completed the ground team poll to proceed with propellant load and launch that happened at T-minus 38 minutes. We began loading propellants at the T-minus 35 minute mark. Falcon 9 is a bi-propellant vehicle. That means we have 2 propellants on board, a fuel and an oxidizer. For Falcon 9, our fuel is a refined form of kerosene that we call RP1, or Rocket Propellant 1. And to burn that fuel, we need an oxidizer. On Earth, most combustion or burning uses oxygen from the atmosphere as an oxidizer,
they are in Florida.
and that oxygen makes up about 21% of the air that you and I breathe. However, in space, we don't have an atmosphere to provide that oxygen or other oxygen-bearing molecules, so rockets need to carry their own. On Falcon 9, the oxidizer is super-chilled liquid oxygen, what we call densified LOX, and we chill it well below its boiling point, which increases its density and allows us to load more onto the first and second stage LOX tanks. Now, currently, we are fully loaded on fuel on the second stage.
That's
Fuel loading is underway on the first stage. That'll continue about until T-minus 6 minutes, when it will complete, and liquid oxygen loading is loading on both the first and second stages and causing those plumes that you see around the vehicle. Now, once fully fueled, Falcon 9's first and second stage combined to carry over 1.1 million pounds of propellant. And we're burned through most of that in the about 8.5 minutes that it takes to land the first stage and to get that second stage into its initial orbit. We'll also need an igniter to burn that fuel and oxidizer, and for that we use a chemical called TTEB. That stands for triethyl aluminum and triethyl borane. When it
Try saying
combines, it
that
produces
5
the
times
characteristic
fast.
green flash that we can sometimes see at the base of the vehicle, and that ignites our Merlin engines. Then those Merlin engines, the 9 at the bottom of the first stage, will begin throwing out their combustion exhaust out of nozzles at the bottom of the rocket, and that pushes the vehicle in the opposite direction. It's a great example of Newton's third law of motion. For every action, there's an equal and opposite reaction. Now, quick update on the weather. We started the day with a 10% probability of violating launch weather requirements. That is to say that we have a 90% chance of go. Been listening to the loops, and we aren't tracking any significant issues that would expect us to hold towards today's launch at 1 a.m. Eastern Time. The weather conditions also look good for booster landing on our drone ship and for fairing recovery out in the Atlantic.
All right,
So
perfect.
with that, the launch vehicle, satellite, weather, and the range are looking good to go for that 1 a.m. Eastern Time liftoff from Launch Complex 39A. Now, as I mentioned earlier, today's IXPE mission is for our customer NASA, and it's the first NASA Launch Services Program mission being launched from Launch Pad 39A.
Impressed.
But it also marks SpaceX's 5th as part of the NASA Launch Services Program missions. Those science missions include the Double Asteroid Redirect Test mission that we launched a few weeks ago, the Sentinel-6 Michael Freilich mission in 2020, the Transiting Exoplanet Survey Satellite launched in 2018, and JASON-3, which launched in 2016. But our payload tonight is a collaboration between NASA's Marshall Space Flight Center, the Italian Space Agency, and Ball Aerospace. The Imaging X-ray Polarimetry Explorer will help us understand fundamental physics of some of the most energetic cosmic objects in the universe by studying the special properties of the X-rays that they emit. NASA's Tiffany Russell Lockett will give us a closer look at the main components of IXPE, where those X-rays come from, and how studying their polarization will help us better understand the universe in the years to come.
To answer some of the biggest questions about what's out there in the universe and what it all means, we need powerful telescopes. NASA unravels the mysteries of the cosmos using observatories in space that study the different wavelengths and properties of light. The Imaging X-ray Polarimetry Explorer, or IXPE, will study X-rays from some of the most extreme objects in the universe, like black holes, in a new way. IXPE will look at a special property of X-rays that has gone mostly unexplored until now. It's called polarization. X-rays come from the hottest places in the universe. Imagine powerful explosions, violent collisions, and strong magnetic fields creating chaos in the darkness of deep space. X-ray telescopes can trace clouds of gas heated to millions of degrees and detect the shower of particles fueled by a feeding black hole. Building on the discoveries of NASA's Chandra X-ray Observatory and other space telescopes, IXPE measures the orientation of X-rays from some of the most brilliant and bizarre objects in space. Like all forms of light, X-rays consist of moving electric and magnetic waves. Usually, the peaks and valleys of these waves move in random directions. Polarized light is more organized, with the two types of waves vibrating in the same direction. You might have heard of polarized sunglasses. Boaters and fishermen use these lenses to reduce glare from sunlight across a body of water.
Yes, we do.
Water reflects light in a way that causes some of it to vibrate in a direction parallel to the water's surface. Polarized lenses block light moving horizontally, but let other light through. Much like the way light changes when it bounces off of water, in space, light becomes polarized depending on where it comes from and what it passes through. By measuring the amount and direction of polarization, IXPE gives us clues about the shapes, structures, and inner workings of all types of objects that shine in bright X-rays. The IXPE Observatory has 3 identical telescopes with 3 main parts: mirrors, detectors, and an extendable mast, or boom, that separates them. Each mirror assembly contains 24 nested mirrors that collect and focus
24.
X-rays.
Damn.
Located at the focal point of the mirrors, sensitive detectors made with international partners in Italy are the secret behind IXPI's unique X-ray vision. They track and measure all 4 properties of incoming light: its arrival time, direction, energy, and most importantly, polarization. Over the 2 years of its prime mission, IXPI will observe more than 50 brilliant objects, like the leftovers of huge stars that exploded into
What
supernovae,
happened when it stunned?
the supermassive black hole at the heart of our own Milky Way galaxy, and pulsars, the dense remains of stars that once were. These observations will help scientists tackle long-standing puzzles, like testing competing theories about pulsars and the details of how Einstein's theory of general relativity works. New insights from IXPI will help us paint a fuller picture of the universe, confirming or confounding our thinking in the years to come.
Now we're just over T-minus 4 minutes away from liftoff
There goes the
of the
Strongback,
Falcon
guys.
9 carrying the IXPI satellite. You can see the strongback arms, the clamp arms that are around the second stage are starting to open. Those are attached to a structure, that truss structure called the Transporter Erector, or the TE. And in preparation for launch, we'll open up those clamp arms. The Transporter Erector will slowly retract away from the stage. As we get closer to T-minus 0, ground hydraulic systems will further pull the TE away, clearing the way for Falcon 9 as it proceeds into its liftoff.
There you go.
We refer to the Transporter Erector sometimes as the Strongback, and you heard that call out on the loops. Now, the Transporter Erector is used to roll Falcon 9 out to the launch pad and raises it into the vertical launch position. It also routes power, fluid, and communications to both the
Stage
rocket
1 lock float is complete.
and the
There we go.
satellite.
Lock one's-
We just heard a call out there for some of those fluids that completed loading on the first stage. We've completed loading all propellants on Falcon 9's first stage.
There we go.
Now, the first stage is connected to the base of that Transporter Erector by a hinge structure, and again, that'll retract further away from the vehicle in preparation for launch. The white gas that you're seeing around the vehicle is just from that chilled liquid oxygen and some periodic venting around the vehicle. When it comes into contact with the moist Florida air, it causes water vapor to condense and forms literal clouds around the vehicle. Now, at this point in the countdown, we're about 20 seconds away from completing propellant load on the second stage. And once that's complete, the propellant loading will be complete on both the first and second stage.
Stage 2 lock float is complete.
There we go.
So with that call out, we've completed loading propellants onto Falcon 9. Coming up next, we'll see some venting from the Transporter Erector. We'll clear out the liquid oxygen from the propellant feeder lines, and you'll see that as some white venting around the vehicle. And then the next activity after will happen around T-minus 60 seconds when Falcon 9 transitions to internal control via its autonomous flight computers.
Gas closeouts have started.
Now, once Falcon 9 has taken over the launch countdown, it'll continue to have control of Falcon 9 through the rest of the mission. The launch director will give their final go for launch if all conditions continue to look good. And then at about T-minus 2 seconds, we'll ignite those 9 Merlin 1D engines for liftoff.
Tower.
Falcon is in startup.
We're in startup, guys. Here we go.
So with that, the IXPI satellite continues to look healthy. Falcon 9 team is tracking no issues. Falcon 9 is in startup.
LD go for XP launch.
Yes! Let's do it, guys.
So the launch director has given their final go for launch. So with that, we're proceeding into the last 30 seconds of the terminal count.
T-minus 30 seconds.
T-minus 30.
Let's
Here we
listen
go.
in as Falcon 9 takes Ixby into orbit.
Water system's about to start. Here we go.
T-minus 15 seconds.
Water thing is probably started by now.
10,
9,
9, 8, 7,
7,
6,
6. Yep, the water system
5,
is on. Look.
4,
4,
3,
2, 1,
0.
0.
Ignition.
And here we go.
Go Falcon. Go 19, ISPE.
Go. And that is on.
Vehicle is pitching downrange.
Oh, that is pretty.
Nominal first stage chamber pressures.
Go, baby, go.
T plus 40 seconds into flight, successful liftoff of the Falcon 9 from Launch Complex 39A
Power and
at the
telemetry
Kennedy
nominal.
Space Center. We're carrying the Ixby satellite into an equatorial orbit, and we just throttled down the 9 Merlin 1D engines in preparation for the next event. That's the point of max Q, or maximum aerodynamic pressure. That coming up in about 10 seconds.
Vehicle is supersonic.
We're in supersonic, guys. Max Q.
Max Q.
So with that, we are through the highest stresses on the vehicle from the combination of our increasing velocity and the decreasing atmospheric density. Coming up next, the next event in about a minute will be MECO, that's main engine cutoff. We'll shut down those 9 Merlin 1D engines
that is
in preparation for the
Jellyfish.
next event, stage separation. The first and second stages will separate, and then at about T plus 2 minutes, 44 seconds, we'll have SES-1, or second engine start number 1. That's where the Merlin vacuum engine on the second stage will ignite to carry the second stage and the Ixby payload into orbit. So again, those 3 events coming up in succession: MECO, main engine cutoff, followed by stage separation, and then SES-1. And this view, looking down on the Merlin 1D engines from the first stage, you can see the plume expanding as the atmospheric density drops off, as we get higher and higher in our atmosphere.
And almost there. Here we go. And MECO.
First stage engine cutoff.
Stage separation confirmed.
There we go. There she goes.
And back ignition.
Oh yeah, there you go. That engine
So
is
those
definitely
3 events successful: main engine cutoff, stage separation. Left-hand side of your screen, you can see a view
That
of the
is
first
pretty.
stage
There goes the
deploying
grid
its
fin.
grid fins, starting its recovery sequence. The
That's so
second
cool with
stage
the
on the
lighting.
right-hand side of your screen, we've got a shot of the Merlin vacuum engine glowing as it continues its ignition to carry Ixby into orbit. Next major event coming up will be fairing deployment. At this point, the second stage
Stage 2 on nominal trajectory.
The second stage is getting to a part of the atmosphere with very low density, so we don't need to carry those fairing halves anymore. We can jettison them back to planet Earth and then attempt to recover them. Again, both of them being new fairing halves flying for this mission.
Fairing separation confirmed.
There we go. There's the vehicle, guys.
There's confirmation of the fairing
That was
deploy,
cool.
the Ixby satellite now getting directly exposed to the vacuum of space.
I don't think
And
we'll
those
see the
fairing halves, again, will be attempting to recover those with our recovery vessel named Bob, which is out in the Atlantic Ocean.
You may see it, but it's going to be iffy.
So if you're just joining us, welcome. We're about T plus 4 minutes and 20 seconds into today's mission.
Acquisition of signal for MENA.
On your screen
Yeah,
is a
signal
view
over
of the
Bermuda.
Merlin
Thanks for tracking
vacuum
on this station.
engine on the second stage. It's completing its first of 2 planned burns to take the Ixby satellite into an initial parking orbit. We had an on-time liftoff at 1 a.m. Eastern Time. The first stage that carried the second stage this far separated and is on its way back to planet Earth. Its next major activity will happen at about T plus 6 minutes and 20 seconds, and that'll be for the entry burn, where it'll ignite a few of its engines to slow down in preparation for entering the Earth's atmosphere. Now, during the entry burn, we'll relight 3 of the Merlin 1D engines on the first stage. That'll start with the center engine, followed shortly after by 2 of the side engines. That'll slow down the vehicle as we pass back into Earth's atmosphere, and we need to slow down on the first stage to reduce the entry forces, which helps us recover and reuse that first stage. Reusability is a key part
Stage 2 on nominal trajectory.
of lowering the cost of spaceflight, which enables more investment into the critical scientific hardware and research. Now, Falcon 9's first stage that supported today's mission will perform this entry burn for the 5th time, having previously done so for the Crew 1, Crew 2, Sirius XM-8, and Sirius 23 missions. And those brand new fairing halves will also re-enter Earth's atmosphere for the first time. The second stage, continuing to burn, its burn will continue until about T plus 8 minutes. And we've heard periodic callouts that we are seeing nominal performance and following a nominal trajectory.
Stage 1 FTS is saved.
On the second stage.
The flight termination system is turned off now. It's saved. Here we go. There we
Stage
go.
1 entry burn startup.
Stage 1.
So
entry
left-hand
burn.
side of your screen, you can see the grid fins and you can see the plume from the entry burn. At this point, we are firing 3 of the Merlin 1D engines. And we're decelerating the first stage, but we're still going pretty fast. So as we're flying into the Earth's atmosphere, that soot is actually getting kicked back. Excuse me, the plume is getting kicked back
Stage 1 entry burn
That's
shut
it.
down.
There you go.
onto the
Shut
first
down.
stage.
Success.
And the plume is carbon-based, so that'll deposit a nice layer of soot on the first stage's surface.
Stage 2 on nominal trajectory.
Nominal shutdown of the entry burn. The next activity for the first stage will be the landing burn. That'll happen at about T plus 8 minutes and 10 seconds. Second stage continuing to look nominal. Now, the engines on both the first and second stage are different. The Merlin engines
Terminal guidance.
on the first stage are optimized for sea level thrust, but the Merlin vacuum engine that you see on your screen is optimized for vacuum. And the difference there is how much we can expand
Stage
the
2
pressurized
FTS is saved.
gases that are being produced by the Merlin
Stage 1
engine.
transonic.
Call out there for stage 1 being transonic, so it's transitioning from supersonic speeds back to subsonic speed. And next events coming up will be second engine cutoff number 1, that's shutdown of this Merlin vacuum engine. And pretty close after, we'll hear a call out for landing burn startup on the first stage.
Stage 1 landing burn.
And back engine cutoff.
So
Yeah,
shutdown
landing
of the
burn
Merlin
and-
vacuum engine. We've got landing burn startup on the first stage.
Ooh, drone.
Left-hand side of your screen is a shot from the drone ship.
Come on, baby, land.
Nominal orbit
Stage 1
insertion.
landing leg deploy.
And correction,
Landing.
that's a shot from the first stage. And on the right-hand side is a shot from the drone ship. We've deployed the landing legs, hopefully for a soft touchdown.
I
on-
think we got it.
Just read the instructions.
Oh, she's on
Stage 1 landing confirmed.
Yeah! We got her.
And
Defensive signal. Kate.
that is a 97th successful recovery of a first stage
she's right
on our
in the
drone
middle.
ship named Just Read the Instructions. This particular first stage having scored 5 flights under its belt. Now the mission
Heck
isn't
yeah.
over just yet. The second stage on your screen is now embarking on its first coast phase, and it's in its nominal orbit. So after this coast phase, we'll light the Merlin vacuum engine for a second time around T plus 29 minutes to put it into the final circular orbit for payload deployment. We'll see you back here in about 20 minutes, but in the meantime, enjoy the space jams and the views of the stages.
We did it, guys. That was the best. Go SpaceX.